Good afternoon, everyone. My name is Muhammad Ali from CML InfoTech. Thank you for joining the session today. Today, we're going to discuss about cabling, basic IP assignment from CCNA, day 5, part 1. Meanwhile, let me know if you have any doubt. As per the last session, we were discussed about IP version 4 from class A, B, and C. And the idea behind that, how to define an IP and the prefix length as well as subnet mask. The last session, we were discussed about IP assignment, the define how to IP assigning to the system. Let's say class A, B, and C. Today, we can start with assigning an IP address to the computers. We have various methodology to perform the lab. So, as an example, we have packet tracer, which is the latest one, GNS3, EvenG, VIRL, and the physical lab. So we can start with packet tracer. Moving on, we can go ahead with the higher end product, including the physical lab. So as you know, if you have more than 2 computers to connect each other, you must need a central product, at least a switch. So I already shared a WeTransfer link where you can download all the necessary softwares. Then you need a Cisco login, either by company associated by or personal. So try to create a Cisco login if you don't have, then to log into the packet tracer software. So here you can see the packet tracer software, which we're going to start with this. And this version is 7.x. The version of the software is 7x. Starting from 7x, you need a Cisco login. And within the software, if you come down, you can see on the bottom line, there are various products. Like if you can see my mouse movement, you can see under devices, where you can see PC, laptop, printer, iPhone, TV, wireless, many stuff. So we just click the required device like a PC and drag it wherever you want it to. So here I have PC 1, 2, 3, and 4. The first task for us to assign an IP address to the system. Okay, I have given few homeworks. Whoever is not submitted, try to submit ASAP. Like for example, if you want to assign an IP to the PC 1, just click PC. You can see the front screen of the system where you have a button on and off. Then you can see on the upper end like a desktop. Within the desktop, you can see IP configuration. Just click the IP configuration, where you can see assigning an IP address, either DHCP or static. For a time being, we can assign an IP with the static. The DHCP, we can later learn it. There are IPv6 as well. So let's say I have given an example from all the classes. Here I would give you an example. Let's say, for example, 25.1.1.1. So 25 is a class A. So the first octet must be same. So if you just click in the subnet mask area, you're going to get automatic subnet mask, which is 8-bit on, the rest of them are off. 25.1.1.1, which is /8 class A. And after you assign the IP address, just close on the top. Then if you go to command prompt, there you can see IP config is the command to see the assigned IP address. Let's say IP config. There you can see the IP address 25.1.1.1 and 255.0.0.0 is a subnet mask. And you need to assign an IP address to the second system. Let's say PC2. In PC2, you need to assign an IP address to the system like desktop, IP configure 25.1.1.2 subnet mask. Now I assign IP address to the two system. Again, one more system, PC3, desktop 25.1.1.3. So now, if you move your mouse towards to the PC1, you can see the IP address of the system 25.1.1.1 and 25.1.1.1.2. Now I would say that you have three systems which need to be in the same network. In order to become they are in the same network, you need to connect each other. So to connect each other, if you have just a two computer, you can use a cross cable. So there are cable within the copper, straight, cross, and rolled over cable. So we can give you a brief idea about it. Let's say, if you look into the UTP cable side, you can see straight cable, cross cable, and rolled over cable. All are UTP, unshielded two-step UTP copper cable, which is Cat6 and Cat6A or Cat7 available in the market. So when I'm talking about the straight cable, of course, majority of the cable that we currently are purchasing as a branded cable from, like, for example, Pandio, Node, and etc. But if you got a chance to do a cable by yourself by putting the RJ45 jack into the cable by manual crimping, you need to know about the color coding. Let's say for the straight cable, the both end of the cable must be the same format of the color. When you open the cable, that you have 8 colors. Those 8 colors is like it's a paired with single color and single color with the white. Like for example, orange color, then orange white color. It's a one pair. Green color and green white, another pair. The way it comes with the orange, green, blue, and brown. Now, in order to become a straight cable, what you need to do, you have to make them, as you can see in the screen, orange, white, orange, one set, green, white, green, blue, white, blue, brown, white, brown. So the straight cable generally used in between different devices, like for example, PC to switch, camera to switch, access point to the switch, access control system to the switch, which are different devices, or server to the switch, or from switch to router, different devices to be connected through the straight cable. Like a pin 1 to pin 1, pin 2, pin 2. The pin 1 and pin 2, what I meant that, you can see here in my screen that orange white connected to orange white, then the green white connected to the green white, orange connected to the way. So within it, like 1 to 1, 2 to 2, 3 to 3, and 6 to 6 are usable cables. I mean data flow. The rest of the cable, which are like, for example, 4, 7, 8, these are dummy for a time being. Those cable are not transferring any data. Those pin within one UTP cable other than 1236, the remaining cable are generally used for carrying the voltage or power, like you heard about before, like power over Ethernet and all. For the data flow, that's we're going to use 1236. Then the cross cable. If you're talking about the cross cable are generally used for same devices like a PC to PC, router to router, switch to switch, kind of similar devices to be connected. For that, again, there is a cable from 1 to 3, 2 to 6, and 3 to 1, and 6 to 2. It's a crossly connected. The first cable goes to the third cable of the other side, and the second cable goes to the sixth side of the other cable, like this. Still here, 4, 5, 7, 8, which are not generally used for data flow, will be used for power over Ethernet. So here in this example, you can see that like a switch to PC or PC to switch a straight cable, and switch to switch or router to router, they are used for the cross cables. Keep in mind, nowadays, when you purchase any branded cable, that can be automatically flexible to connect either from switch to PC or from switch to switch. That can be automatically detectable. You don't need to worry about. If you are purchasing a branded cable from like a Panduit or Norden or etc. Then there are another cable, which is the final cable within RJ45 called rolled over cable, or we also used to call that console cable. Generally, these cable is used for configuring the devices. Those are straight opposite, like the orange white of the first side will goes to the last side of the other side, just opposite of the cable. But generally, we will be purchasing the console cable by manually from the shop. The blue cable called rolled over cable. Then again, you can see that serial to USB converter, the meaning that whenever you purchase the serial or the console cable, you can see that the other side of the cable is generally COM port. The COM port is not available to all the laptops nowadays. So therefore, we used to have the serial to USB converter in order to convert the cable from serial to. So the every majority of the laptop will be having the USB port, but the console cable doesn't have the USB port. Therefore, we're going to use the converter in between them. So you can see in the picture that I'm connecting to the router for configuring from the console port to the system, where the system will have the converter to convert from RJ45. Okay, so back into the scenario. What we are trying to explain that we are used to connect just a two system between PC1 to PC2. We can use as cross cable. So if you look into the bottom, you can see my mouse movement. So generally, the console port means every network device will have a specific port in that device for configuring. I'll show you in the next slide how it is. The console cable and console port, there are two. Do not be confused. Console cable is the cable which we use to configure any network devices. So the console cable look like this. We can purchase from the market, from Sofitel for any shop. Or sometimes before, when we purchasing any Cisco switches, the console cable comes along with the Cisco. But keep in mind, if you purchase any extreme networks branded switch, generally you cannot use the console cable, what you can see in the picture. For the extreme network switches, will have a separate reddish color cable, which is available along with the box. You cannot use any different cable. Moreover, majority of the network devices, when we purchasing, the configuring cable will be available along with the product. Console port, just keep in your mind. I'll give you an example after 2-3 slides. So we back into the diagram that we have two systems to be connect each other. As I said, when you're connecting two device with the two same devices, you can use cross cable. So if you come down, you can see my mouse movement that you can see the cable connections. There you can see many cable. Like you can see the console cable, straight cable, then you can see cross cable. I'm gonna click the cross cable, just one click in the cable, go to the PC, again one click in the PC. There you can see where you wanted to connect. You can see that fast Ethernet here. Then move to another side to the PC2, click in front of the PC2. They're gonna ask where you want to connect. Again, say fast Ethernet 0. So now your two systems are connected each other. Okay, they have become one network. How will you know that? You can see the green color on the cable, which it's become up. Now you go to the PC1, click PC1, go to, let me show you on the screen. So after you click PC1, you can see the front screen of that. Earlier, we have entered to IP configuration for assigning an IP, 25.1.1.1. Okay, click command prompt. There you can see a command called ipconfig is a command for configuring the IP address. So you already assign an IP 25.1.1.1, and you know that your second PC where you connected is the IP called 25.1.1.2. Now you wanted to check the reachability, whether they are reaching each other or not, the reachability between PC1 and PC2. Always, I said before, every communication within the network infrastructure, whether it could be wired or wireless, or PC, laptop, phone, could be anything, they are always used protocol. So to communicate between two computers or to check the reachability between any device to any device, we're going to use the protocol called ICMP. What we call ICMP, Internet Control Messaging Protocol. ICMP is a layer 3 protocol, OSI layer, layer 3 protocol. And within the ICMP, there are multiple functions. One we call echo. The second one called echo reply. Echo means, let's say I'm trying to check the reachability from PC1 to PC2. When the PC1 send a reachability message to PC2, that's called echo. And the PC2 will reply back either 100% successful or in between any percentage or 0 success, whatever it is. They will reply back. That's called echo reply. And within ICMP from layer 3 to test the echo and to test the echo reply, they are generally having two commands within ICMP. One we call it as a traceroute or traceroute. The traceroute and the traceroute command within ICMP of layer 3 is used to check the path. Are they going the right path or are they going bypassing with the wrong path? What does that mean? That as an example, you can think that your PC connected to the internet via Vodafone and via Uridu or via BSNL. You do not know how the traffic is going out from your computer to the internet. Maybe you're going to say that my X service provider bill is always higher than the Y bill. So you need to confirm that through which service provider my traffic is flowing. Therefore, we used to have a command called traceroute and traceroute to find the path. We'll do the lab and we'll let you know how it is. The other command, which we're going to do lab right now, called ping, P-I-N-G. Ping. Ping is the command to check the reachability. Traceroute or traceroute command is to check the path. Which path is traveling the packet to the destination, whether X path, whether Y path, whether the right path, whether the wrong path. There is a mechanism called uh, reverse route forwarding, or RPF, which we can inform physically to a device certain amount of data should go through one path and certain amount of data goes to another path for the load balancing. So we're going to talk about ping. Ping is the command from the ICMP protocol to check the reachability. Let's say I'm going to PC1. So here I have given ICMP as a layer 3. Within that, there is a trace it and the ping command. By using ICMP protocol, we will come to know echo and echo reply. The echo means if I say something to you, you must need to hear it. So that's called echo. So I'm sending to you something. So when if I get echo, which means my packet has reached the destination. And when you receive something, you need to reply back to me that yes, I received. It's a three-way handshaking. It's called echo reply. So let's say we go to the PC1. PC1. Now within PC1, I need to know where do I need to check. So let's there's a command called ping 25111. The 25111 within the same computer, if I enter, this is called self-testing. Here you can see that I have sent 4 packets and I received 4 packets, which means 0 loss. Instead of giving the same system IP, even I can give ping.127.1.1. If you remember, I would say I've informed that 127 within class A is used for self-test, or even I can do localhost. Okay, it requires some additional information. Let's see that. For now, I need to ping to 25112, my fire-end system. This is my destination system. Here you can see that reply, echo reply. How we can in deeply know about echo and reply. We have a topic called access list, access control list, to filter a certain amount of traffic. Either it could be IP, or it could be protocol, or it could be any circumstance that we can assign, and we can define what needs to allow and what needs to block. As an example, I would say my as I'm an admin, if I have 10 computers, I need to inform, I need to give a policy to my old system says that the specific system shouldn't access the Facebook during working hours, or they have certain amount of blocking in permit stage. That is all I can define with an access control list. There we can deeply understand about the echo and echo reply. So here you can see I received the reply. Now let me try typing to 25113. Actually, we have a system 25113. The system is this one, 25113, but I have not connected to my network. Therefore, when you try to ping, you can see that request timed out. There is a multiple messages, request timed out, destination host unreachable. We will learn it in deep. So now here you can see that you send 4 packets and you received 0, so you have 100% loss. The reason where I cannot reach to 25113 because the 25113 are in the same IP range but not connected into the network. The reason I have not connected to the network because I have not used any central device. I just simply pull the cable. Even if you wanted to connect to my PC2 to PC3, I need an additional NIC card within PC2, but I don't have. There, where you have more than 2 computers in your design, you need to have a central device called at least a switch. Now we're going back to remove this cable. Let's right click to remove the cable. You can see the into mark. Click the into and move it. Now I don't have a cable connected between PC1 and PC2. Now I'm going back to the PC1 and try to ping to PC2. You cannot because you have not connection in between. Now we're going back to We're going back how we can connect each other. Okay. Let's say in order for you to connect each other, multiple system within your network, you need a network device called switch. You can see this is just an example for one of the switch, Catalyst 2960, which is the older model of the switch. Currently, we do have 9200 and 9300 from 900 series of the family, the latest switch model. Now you need to connect to the switch. So let me give you another example how the switch looks like. Do not be confused. When you have more than two devices, it could be PC, it could be camera, it could be any edge devices. You need a central product to connect each other. That's called a switch. So now, how a switch look like? I have also shared you one catalog you need to install, and you need to have a Cisco login to access this. Hope you can see my screen. Here, this is the product catalog. Okay. You can see many devices on the right side of the screen. There you can even see switches. Now here you can see the switch, let's say for example, Catalyst. The CAT OS is one of the OS which the Cisco has purchased from the Catalyst series and made them as Cisco own OS. So instead that, what we can do, we can see if I click a Catalyst switches, you can see many switches here. Okay, we will take one of the example. Now I'm clicking the Catalyst 3750, or let's see, do I have a 2960 here? Let me search 2960. Yeah, now you can see here Cisco 2960 X series of switches. Let me double click that. Hope you can see my screen. We can see here. We can start talking from this side. You can see here two ports. One called, the first one is called management. You can see the same yellow color, the management. The latest majority of the switch model will also have the management port in order to send the management traffic separately. Like the internal port of the switch is always used for data travel, and they have the separate switch for the management. So we call it as a keep alive. I'll talking about the management port usage later. The bottom port, you can call it as a console port. So the question for someone asked for the console port. Let's say you have a switch and the switch needs to be configured. There are two models of the switches, by the way. One is unmanageable switch and the second one is a manageable switch. The unmanageable switch, you cannot do any configuration in it. It's a simple switch which we can purchase with a low cost. You cannot do any configuration. So what do I mean by the configuration that you need to do in the switch? Like for example, in a simple way, there are many topics to discuss about when talking about the configuration. But in a simple way, when we're talking about the configuration, that like for example, you need to give a port security. As an example, you have port number 1 and port number 2 that you connected two devices. Okay. Let's say you connected two IP phone into port number 1 and port number 2. Now, any people can come and remove port number 1 and they can connect their own devices. What if they connected to another devices? Let's say I'm an employee of the company. I purchased, I bought my own system to the office for upgrading or for the better internet or better upgradation, something. I bought my system to my office and I removed my office laptop and I connected my personal laptop to the system. What is the drawbacks if I connected something? I can act as a man in the middle. I can act as a DIA. I can act as an attacker in my office, and I can forcefully do some ransomware attack or do some any unwanted traffic that I can forward from my computer to the complete network. So therefore, every port, they will be bind the MAC address of the connected system into to that specific port called port security. So if I connected any another devices within that system, the port will be going to the blocking state. They won't work. That's one of the reason, and there are many. So in order to achieve those set of configuration, or like to assign the specific port speed or port authentication, like to verify the username and password, something like this, I need to do a configuration within that device. So in order to do a configuration within that device, I need a management switch. I need a configuration capable switch. So if I purchase the configuration capable switches, I need to do configuration by manually. So therefore I have a console cable, and that console cable I connected to my laptop, and in within my laptop, I'm going to use a software or the let's say software called Putty. In order to configure my network devices, it could be router, it could be firewall, it could be switch, or it could be any respective product. You can see my screen called a Putty software. We will teach you how a Putty can be used in the later, but what I meant that you have a console cable. Your console cable is connected one side to the switch where the console port you can see. സ്വിച്ചിനകത്ത് കൺസോൾ പോർട്ട് എന്നൊരു പോർട്ട് കാണുന്നുണ്ടല്ലോ, അതിലേക്ക് കൺസോൾ കേബിൾ കണക്ട് ചെയ്യും. എന്നിട്ട് അതിന്റെ മറ്റേ എൻഡ് ലാപ്ടോപ്പിൽ കണക്ട് ചെയ്യും. ചില ലാപ്ടോപ്പിൽ ഡയറക്റ്റ് കണക്ട് ചെയ്യാൻ പറ്റില്ല. ദെയർഫോർ നമ്മൾ അതിന് സീരിയൽ ടു USB കൺവേർട്ടർ വെച്ച് കണക്ട് ചെയ്യും. അങ്ങനെ കണക്ട് ചെയ്ത് കഴിഞ്ഞാൽ how I can configure. So there you need a software called Putty software. We'll teach you how to use the Putty later, inshallah. So now going back to the screen, there you can see that like console port and COM port, and you can also see another type of console port which currently you can also available a cable called type C console cable. There you can, one side is a type C and the other side is a mobile chargeable cable. One side of the USB and one side is this kind of cable. And even you can see two USB port where you can connect your USB pen drive directly to the system for uploading and downloading the configuration. And starting from here, you can see start port number 1, and you have a port number 24. So 24 ports of a normal switch. There you can see port number 1 to port number 8, which is act as a PoE. What does it mean? That some of the device required a power where the power can get it from the switch directly, but in this specific model, you can get the power directly from port number 1 to, you can use port number 1 to port number 8 for the power. We'll talk about power later. Also, you can see that the port number 25 and port number 26, which is the copper port, and you also have a fiber port here, which is the SFP. Small factor ports, which you can use for the fiber connectivity. It's just one example. I'm just showing the backside of the ports. Now I'm just turning the back of the switch. Okay, here again, as you can see that rear view on the top. There you can see in the back side of the switch, power port for the power supply. This switch will have a single power supply. And then you can see here is a stacking cable. And this is a stacking port. We'll talk about stacking later. Stacking is nothing but to make a multiple switch as a single management perfect. We'll talk more about stacking later. Okay, this is one series of the switch. And if I go for another model of the switch, let's say switch 3750. Here you can see one console port, and there are 24 ports of the normal port. Then you have two more ports extra. And I'm just dragging the backside of the switch. You can see here also you have a stacking cable. Then we have a single power unit. So thank you for joining with us today. We just explain about assigning an IP to the system and the switch basic information. So this is the session for day 5, part 4. Request you to rejoin again for the part 2. Thank you.